Hello, this is Chris Kupchik from Team 13, microphone preamplifier with digital pitch correction. I will start with a quick overview of the digital pitch correction unit. The purpose of this module is to read audio signal into the buffer, if necessary modify the signal, for example change the frequency, and finally write data back into the output buffer, all done under 50 milliseconds or less. The main component of the system is the single board computer running Windows operating system and our custom C++ application responsible for real-time signal processing. Next, we have a USB serial adapter used for the serial communication between a single board computer and the host PC. In the front, you can see an OLED display with a simple navigation menu and a control knob. On the left, you can find the input and output ports. We also added cooling fan and a speed control because we had some issues with the CPU overheating. Also on the right side, we have a terminal block connected to 5 volts power supply. Now I will switch to the demo application on my PC so you can see and hear unit in action. So this is our custom C++ demo application we created to visualize input and output signal. It is connected to the single board computer where all the calculations are actually made. On the right side, we have a menu where we can change the pitch up and down, or we can enable pitch correction, or we can change pitch correction return speed. So right now, as you can see, there's no signal going in. So I will use a tone generator to simulate the signal going in. As you can see, this is a 300 Hertz signal going in, and there is nothing, we don't do anything right now with the signal, so the same signal is going out. But if I want to shift the pitch on the signal, I can easily do it, and I can move it up, and I can move it down. And the pitch shifting is pretty stable, so if I simulate the input signal a little bit, you can see that the output signal is always shifted. So the next thing I want to show is the pitch correction. And to simulate that, I'm gonna try to make the input signal as something like a D#4, and if I enable the pitch correction, system should correct that to D4, and it looks like it's working correctly. And the slope you can see is just the delay that we can set up as a return speed. So I can set it up to faster speed, and as you can see, it just takes faster